So in all of my previous designs, I've been using a very simple simulation-based test bench to verify the design. And in most of the designs, what I've been doing is that I would code my RTL here and will then have a very simple test bench connected to it. This test bench did not have any checkers, so there were no checkers. And it was also a very simple, straightforward simulation-based test bench, which performed very bare minimum. And what it just did was that it will just generate clock and randomize the inputs which are passed on to the RTL. So that is how I've been doing most of the testing. But I realized that the designs which I've been doing now are getting complex and it would make sense to verify them soon. And that's why I wanted to improve on the test bench side of things going forward. So in the hardware industry, if you would want to classify your test benches, those would generally fall into two places. Um, you could either have simulation-based test benches or you could have formal-based test benches. So I wanted to first focus on the simulation ones, and then later in the challenge, I will look into the formal based test benches as well. So in the simulation based test benches, you could still have the test benches constructed using different methodologies. You could either have a very simple SV based test bench, which I've been doing here, and it does not do anything. It just provides the stimulus which is needed to dump the waveforms, and you could then look into the waveforms and try to verify the scenarios. You could then have some class-based test benches which are again constructed using system Verilog. You could either use UVM to have your test benches constructed, or you could even write them in different languages using C++ or even Python, where you could construct your entire test benches. Going forward, I would want to take a look at the simulation based test benches, and that to focus on the class based before we look into the UVM based ones, because these two are actually used quite widely in the industry, and it would make sense to have some examples covering these. Um, since for SP we've been only looking into the RTL constructs, I would also be going through various different constructs which are basically used for the verification methodology, which includes your classes, various OOPS concepts, as well as the ability to randomize certain objects with constraints. So in this video, I just wanted to give a very quick overview about how a typical SV-based test bench would look like. And in the next days onwards, we would start putting out different pieces, which are then needed to construct the entire SV-based test bench. So if you would want to take a look at what we want to verify is that we have our RTL here, and we want to verify this using a SV-based test bench. So how you would use your test bench to verify your RTL is by driving the inputs of your RTL using your test bench and then monitoring the outputs generated by the RTL within your test bench. Your test bench would also have a model which would do the cycle-based comparison between the outputs produced by your RTL and the expected outputs by your test bench. That way you would have some sort of checking being done, as well as you will be able to drive random stimulus using your test bench into your RTL. The way you would want to drive your signals through the RTL is by using an interface. So interface is the boundary between the test bench as well as the RTL. So let's call this as the interface, where you would be able to drive and monitor the inputs and outputs. So this would be your IO, and then the interface would be passed on to your class-based environment, which basically constructs your test bench. So a generic test bench would usually have certain classes which would then be constructed together in order to form the complete test bench. These different classes are basically your test class, followed by your ENV. Within the ENV, you would have a generator which generates random stimulus, a driver which is responsible for driving that random stimulus onto your interface, which then goes into your RTL, and then you would have a monitor which monitors the output of the RTL and passes this on to your scoreboard. The scoreboard is the one where you would have certain checking mechanism implemented, and you would use that to flag any mismatches which you see. And all of these are then constructed together to form the complete class-based testing environment. So let's imagine that we have this testing environment here. So the above portion would be your test. You would then have your environment class, which is the place where you would instantiate all of the different components like monitor, driver, and other stuff. So this is your environment, which will then have your generator, scoreboard, driver, and a monitor. So both the monitor and the driver will be sending the transactions to the scoreboard such that the scoreboard knows what is the input being driven and what is the output being monitored. And the outputs from your RTL would be connected towards the monitor, and the outputs from driver would be driving the interface here. So this would basically be your inputs to RTL, and this would be outputs from the RTL. So as you can see that we need a lot of these things together in order to form a complete simulation based test bench. And in the next days, I would be building each of these components one by one. And I would also be discussing that how you would have a class constructed, randomize a certain object using constraints. How would you construct your driver, monitor? How would you communicate between driver and the scoreboard using mailboxes? All of the other stuff and the other things which we need in order to have this entire structure constructed. Once we have all of the different pieces of the puzzle together, then we will bind them together in order to have the complete test bench and use this particular test bench structure to verify the different designs which we've been doing in the past few days. All of this sounds very exciting, and it would be great to see this test bench environment up, and then we'll be able to verify all of the designs which we've been doing previously. I am excited to get started on this now.